Hi, everybody. Welcome to the assignment 3 AAV Remus 100. We're going to give some updates as we get to the end of our project here, but right before our final presentation.
Okay, so here is our control scheme. This is actually our full block diagram. So basically the control is everything but our plants, so the elevator, actuator, and vehicle dynamics. So as you can see here, it's a double feedback loop that's in parallel with the pitch rate sensor and pitch gain being outside of our plants and part of the control. We also have 3 different commands coming in that we're kind of neglecting for simplicity in this project. And those are the pitch command, commanded elevator deflection, and the actual elevator deflection.
To analyze the system, we need to find a reasonable gain for the control for the main command. And to do that, we're using a Roth table. We did it once, and then we need to change the transfer function that we're analyzing. So we're going to do it again, get another range for that gain that is possible to have a stable system with. And then hopefully within that, we can select a reasonable gain that gets our system response in the speed we want it and the accuracy we want it. And then part of that is using the steady state error to analyze that, using Simulink with the different gains that we have within our range, kind of testing a bunch of them, finding out which ones can get us as close to 0 steady state error, because it is simplified a higher order system with up to s cubed in one of our terms. We could have down to 0 steady state error as long as we select the right gain. We were trying to approach the right value. And then just kind of selecting what has that overshoot rise time and settling time that we need for a reasonable system response.
So as Asher said, we're going to use Simulink. Here is the really large Simulink model that we're going to use, but we're also going to neglect everything in the green box, because that is the fault detection part of the Simulink model, which we're not going to get into. So we're going to take that out. Yeah.
So for our results, we found a transfer function from the UFSS, and this is not the complete transfer function that we will be using, but it's similar, and so we'll follow the same steps that we did for this one. And this is just the block diagram of the UFSS. So we also worked on our report a lot this week. We made a functional diagram that you can see here, and that you also saw earlier. And all our members are working in overlay.
All right, so obviously the team presentation is going to be due next week. So we set up some things to finish up the project. We're feeling a lot stronger after this meeting as far as our ability to finish this project. So the first thing that we did is set up our future meeting times, make sure we have enough time to knock everything out that we need. And we broke up the report sections based on our skill set to work on between now and the next meeting. The Teams outline is currently being created so we can show how we were interacting, because we did not use Jira, we used Microsoft Teams. So we're working on being able to show that that is also a good system to use. And then we're working on an outline to connect this back to the ABET outcomes. Perfect. All right, well, if you have any follow-up questions that you want to talk to us about, these are all our contact information. We do look forward to finishing this project and sharing with you our final thoughts.